Now we're going to focus on the adjacency matrix. This is a flashback to the matrix unit that we did previously. So keyword is adjacency. So we just figured out in the vocabulary unit that adjacent means that it's the vertices are connected by an edge. So when we look at our picture, we can see that the one that we have here, adjacent to A, 2 connect from A to D. We have one that connects from A to E, and one from A to F. So we can see over here, A to F, A to D, and the second one that goes from A to D. Then we also have that A to E. So we will put it in a matrix, which will allow us to organize the information better. Because I'm going to put in a matrix, I'm going to just put some lines that's going to help me keep it organized and I can write straight. But you will not have to do this if you don't want to, and you will not see it with lines on them on your own. So one thing that is awesome about this matrix is when you add up all of the numbers in each row or the columns, that total number will represent the degree. Let's go ahead again, flashback. Degree is the number of edges that each vertice has. So A has 1, 2, 3, 4 edges. So that means when we're looking here, A's graph, its line is going to have a total of 4. And we can either add that up or down. We're going to fill in 2, 3, 4, 6, 3. I want to go ahead and put those in. And now let's go ahead and fill in the matrix. I'm looking to see, it's going to be reading just like if it was a multiplication chart. A and A. Do we have a line that from A that connects to A? No, we do not. So we'll put a 0. Do we have a line that connects from A to B? No. A to C? No. A to D? Yes. We have 2 lines that actually connect from A to D. One from A to E, one A to F. So now when we add up 2 plus 1 plus 1, that's going to give me 4. So let's look at B. B, we can see here, the adjacent vertices is D and C. So there's 1 for D, 1 for C. We add those up, it gives us 2. That's how we know all of the other ones are zeros. C connects twice to E and 1 time to B. That added together gives me 3. So we fill in the rest with zeros. Now, I know you're like, oh, I can do the rest myself, but let's just go ahead and work it out together. A to D was 2 times. The D connects to B 1 time. D connects to F 1 time. The rest are zeros. Add that up, it equals 4. Now E is special. Remember, E is the one that has a loop that goes from 1 right here, leaves E, and then it comes back to itself. So understand that this loop, it's going in both directions. So there's actually 2 lines that circle around. So does E connect to E? Yes, twice. That is key, because don't put once because you see 1 circle. Because remember, we zoom in and we ignore what the rest of the lines are doing. We don't know. So we only see 6 lines. 1, 2, 3, 4, 5, and 6. So they're both leading out and leading back into E. We have 1 from E to A, 2 from E to C, 1 from E to F, and we add that and we get 6. So please remember that when you're looking for the second one, if it's a loop, that's going to be that right there, E to E. And those would be listed on the on the diagonal. So they'll be in one of these diagonal corners right here. And our last row, A connects to F one time, or F connects to A one time. B does not, C does not, D connects one time, E connects one time. We add that up and we got 3. Now remember, if we add the columns as done by the columns, that's going to give you the same numbers. That is how you read and create your adjacency matrix.